Alrighty, welcome to lesson 2.6, some of my favorite lessons. In this one, we're going to talk about finding areas of shapes that are not circles. Alright, so we're going to talk about formulas of common shapes such as parallelograms, triangles, and how to calculate those areas. And then we're going to talk about composite shapes. So first, let's talk about those common shapes. So first, we need to talk about a little bit of vocabulary. The first word we're going to throw out there is quadrilateral. I don't like using black ink. Let's use a different color. Purple. Quadrilateral. What this means is a four-sided polygon. And if you forgot what a polygon is any closed shape. Right? So for example, that is a polygon. This isn't because it's not closed. Right? So any closed shape. A quadrilateral is a four-sided closed shape. Quad means four, lateral means line. So we have different kinds of quadrilaterals that you should already know. A rectangle has four 90 degree, whoops, not 90 degree angles. Okay, that's what defines a rectangle. A square is a special rectangle with all sides equal. So that also means that it has four 90-degree angles, but it also has all sides equal. And a parallelogram, what that is, it has four sides, so it's still a quadrilateral, and opposite sides are parallel. So opposite sides are parallel. So what that means is, if I was to draw a couple examples, one could be, imagine that this is perfect, one could be a rectangle. Because these two sides, if they continued on, they would go on forever without crossing, so they're parallel. And these two sides, they're opposite, and if they went on forever, they would never cross. They're parallel, so that's a parallelogram. Another example, this kind of slanty figure here. Right, so again, opposite sides are parallel, which makes it a parallelogram. So we already know, when we're talking about area, we already know the area of a rectangle. Okay? The area of a rectangle is length times width. Right, so we're going to call this W and we're going to call this length, so we can figure out that area. So remember, area is the space inside, so all of this purple stuff is the area. So width is here, length is here. Now if I was to rearrange this just a little bit, and move this bad boy over here, all of a sudden that's no longer a rectangle, that's a parallelogram. Now, but you'll notice some sides stayed the same. This bottom side is still the bottom side. What used to be the width of the rectangle is now the height of the parallelogram. So now we just change the vocabulary a little bit. We don't, when we're talking about parallelograms, we don't say length and width. The bottom we're going to call the base, and this we're going to call the height. So remember, it's still, just because I changed the letters, the area of this thing is still length times width, but now we just changed the letters, B and H. So now the area is the area of a parallelogram is base times height. That's our formula. Pretty cool. All right, let's talk about how that relates to a triangle. So here's a parallelogram, and I got the base and the height marked. All right, so I know the area of this thing. The area of this thing here is base times height. Now what if I was to cut this thing in half and throw one half away? Now I have a triangle! Right, so we've used this formula before, but now we're just going to talk about where it came from. So, because I threw this half away, I also have to cut my formula in half when I'm talking about a triangle. So all I did was I took the base times height, and now since I'm talking about a triangle, I divided it by 2. So you can rewrite this formula a bunch of different ways. It's still all the same. So you could say that it's base times height, then divided by 2. You could also say that that is 1/2 times base times height. You could also say that that is 0.5, which we know is 1/2 times base times height. These are all the same formulas for a triangle. Oh, one more, if you don't like fractions, you could say base times height and then divide by 2. Same thing, all of these. I don't care which formula you like, use the one that you're most comfortable with. Alrighty, let's do some examples. Alright, example 1. 30-inch square cloth is folded along the diagonal to make 2 triangles. What is the area of each triangle? So when I say 30-inch square, that we're not talking about the area right there. We're talking about a square that has a side length of 30. Alright, so I've got a square, and each side length is 30. So if I was to cut this thing in half, I want to know the area of that triangle. Alright, so to figure out the area of that, area of a triangle, I'm going to use base times height, then divide by 2. So for this particular triangle, my base is 30. And my height is also 30. So I'm going to have 30 times 30, then divide by 2. Alright, so I'm just going to run to my calculator here. 30 times 30 equals that, 900. Now divide by 2. Bam, 450. 450, and since we were talking with inches, my area is inches squared. That's it. Let's do another example. Example number 2. A snakeskin is covered in parallelogram-ish shapes. So you can kind of see here, they kind of look like parallelograms. Right. So one of the small parallelograms is pictured right here. What is the area of this parallelogram? So the area for a parallelogram, the area we said was simply base times height. Alright, so first, well, I guess the only thing to do in this question is figure out what means what. So the base is the bottom here, and the height is how tall it is. Not how long the side is, but how tall. So that's my height. So this number here I actually don't even care about. So my base is 3 times my height is 2.5. Alright, let's pull up our calculator here, or you can do this one in your head. So it should work out to 3 times 2 is 6. That should work out to 7.5. Yeah, let's try that. So 3 times 2.5. Bam, 7.5. And because we're in millimeters, my answer has to be in millimeters squared because we're talking about area. Alright, so that's using those first 2 formulas. Alright, I'm going to do the next part here in a separate video. So we'll call this next video 2.6b. Alrighty.